Okay, we're going to use the arc length formula to show that the circumference of the circle, x squared plus y squared equals 4, is 4 pi. So let's get some things that we can work with here because we don't necessarily want to work with a super nasty function. If I were to graph this circle, it's got a radius of 2. So it comes out here to 2, comes up 2, comes over here 2, and it goes down 2. Okay? And so if I draw this circle, which it's not very good, so sorry. Oh, that's horrible. Let me try again. So football circle. That's not too bad. That's not too bad. Okay. So basically what I can do is this. What if I look at just the part of the circle that's here in first quadrant? Just this part right here. Okay. The x values that we're running through go from 0 to 2. Okay? And so if I just look at that one part, that would give me this one little teeny tiny piece. Okay? The reason that I want to look at just this one little teeny tiny piece is that when I set my equation up and solve it for x, I only have to deal with the positive square root part. Okay, remember we're trying to solve for y, so we'd have y squared is equal to 4 minus x squared, and then I take the square root of that. So the square root of 4 minus x squared is the equation that I would use to graph this. But we're only looking at the positive part, and we're only looking from 0 to 2. So when I set my equation up here, I can look at just the function y equals the square root of 4 minus x squared. Or y equals 4 minus x squared to the 1/2 power. Okay, so one of the things that we're going to have to use is our arc length formula. And arc length says that, we'll just use length, is equal to the integral from a to b, in this case 0 to 2, because that's the only part that we're looking at, times the square root of 1 plus y prime squared. All right, so I need to figure out what y prime is. Back to this guy right here, y prime is 1/2 times 4 minus x squared to the negative 1/2 power. Okay, that's the derivative part. Now I have to chain, because whenever you take derivative and you have stuff in the inside, then you've got to chain that stuff out. And so that would give us then times negative derivative of 4, 0, okay, derivative of negative x squared, negative 2x. So I can simplify my problem a little bit, and y prime becomes, the 2's cancel, and I end up with negative 1 over 4 minus x squared to the 1/2 power. Okay? All right. Not too bad. So let's put this into our arc length formula. Our arc length then is going to be the integral from 0 to 2 of the square root 1 plus the derivative squared. I'll go ahead and write it in here, negative 1. Oh, whoops, that should be an x up there. Let's see here. This should be a negative x, not negative 1. So this guy would be negative x over 4 minus x squared to the 1/2 squared. Oof, that's really big. Okay, go ahead and simplify this one step. This would be 1 plus, and then negative x squared is positive x squared. And the square root of 4 minus x squared is 4 minus x squared. So I wind up with this fraction right here. Now, what we want to do is we want to try and get to 4 pi. So in this situation, normally I would say, hey, use your calculator. But if we're looking for a specific value of 4 pi, that's not really a calculator phrase. So what we're going to do is get a common denominator here and combine these fractions together and see if there's a way to maybe clean this guy up and get something that I can use. Okay, so this side needs 4 minus x squared. This side just needs 1, so he's all good. And what we end up with then is 4 minus x squared plus x squared. And we wind up actually dealing with 0 to 2 of the square root of 4 over 4 minus x squared. Now, don't panic a lot at this point in time because you're looking at this thinking, how in the world am I going to integrate this? By the way, there should be a dx back here and a dx right here. Don't panic. Notice that if you have your trig sheet or if you have a sheet of different integrals, run through the arc inverse trig integrals. And you'll notice that this guy right here strongly resembles, he's not quite ready for it yet, but he strongly resembles the arcsine function. So what we need to do is get it into a form that arcsine can be used. Okay, so back up here to the top, we're looking at the integral from 0 to 2. And I'm going to do a cool trick here. I'm going to factor a 4 out from everywhere. Okay, and if I factor the 4 out, what that does is it cancels the 4 on the top and the bottom. All right, but this is going to be a really little bit on the unique side. The ones, okay, 4 divided by 4 is 1. Okay, 4 divided by 4 is 1. But 1 divided by 4 is 1/4. Okay, so all I did was factor out a 4. I kind of left out that little basics factoring step, but it looks like this. Now, 1/4 x squared, 1/4 x squared is equal to x over 2 squared. And this guy right here is what allows me to get to the arcsine. Okay, so watch my next step. I'm going to have 0 to 2 of the integral of 1 over 1 minus x over 2 squared dx. This guy right now, this is what the arcsine looks like. Okay, that's what the arcsine looks like. So what I do is I integrate that out and then times the derivative on the inside. So now back over here with all my limit process stuff, I'm going to look at the limit then. Well, let's do this. Let's do this. Let's go. When I integrate this, I'm going to have the arcsine of x over 2. Okay. And so what I want to do is I want to look at a way to find the total length of everything now. Okay. And so I need to keep in mind that I'm doubling all of that. All right. So what happens is I'm going to have a 2 here. Okay, 2 in front, and I'm evaluating it from 0 to 2. Okay. Now this all looks well and good. The problem is when we go back to our setup here, this guy right here. This guy right here tells us we're going to have an improper integral. And the reason he tells us that is because any value that's equal to 2 cannot go in there. So what we're going to do is we're going to set up our limit as b goes to 2 from the left, and then we're going to change this 2 right here to a b. Okay, so There's your setup on this guy. Doesn't look too bad, right? All right, I'm going to finish the problem down here under Gabriel. So to finish off this problem, what we're going to do is we're going to put our stop minus our start in. And that's going to give us the limit as b approaches 2 from the left of 2 times the arc sine of where we stop, which is b, minus the arc sine of where we start, which is 0. Okay, and now I can put the 2's in here because it's going to be all right. And this needs to be arc sine. All right, so what angle gives us a 0? Okay, what angle gives us an arc sine of 0? Well, 0. Okay, and then on this guy right here, I'm going towards 2. So what I have is b over 2. Well, I can substitute this 2 into this spot. So what angle gives us the sine of 1? And in this case, it would be pi over 2. Okay? So what I'm going to do is I'm going to have 2 times this guy, which is going to give us pi. Okay, I misspoke right here. I want to come back to this guy for just a quick second. When we do this, when you look for your arc sine, that's going to be 1 over 1 minus u squared. Okay, that's the arc sine setup. So in this case, my u equals x over 2. So du equals 1/2 dx. When you solve that for the dx, you get 2 du. That's where this 2 came from. So when we sort it out, this pi right here is the length of this one part of the circle. So pi is that length right there. Well, I've got 4 of those. So when I do this times 4, I get 4 pi. And there you go. Hey, that's cool. We just used calculus to solve a geometry problem.